record on this computer, and I'll put it on the screen. Right, so God bless you. Now, so we're showing you how about to do. So await termination is just if you don't care whether the thread's complete or not, okay? So the threads, all your threads will stop after your service, which is looking after your thread, so all your tasks will stop after 10 seconds. That's all await termination does, okay? Now, so we are going to do, let me see now, make sure I have the right one here. Yes, Kieran.
In that situation, you're safe to take tests and 5 of them are done. You just have to find out which 5 are done.
Yeah, you would. So my advice is don't use it.
Okay.
As simple as that. I wouldn't advise you to use it. Okay. So, right now, this is scheduling. So I don't know what the fuck this is here, so I'll just comment this out for now because I don't know what it is. I don't know what I was trying to do there. So I'll comment all that guy out. Right. So I'll leave it there. I don't know what it is. Right. So this is scheduling. Now, what's scheduling? This is scheduling certain tasks to be carried out at certain times. Okay. Now, these can be running continuously. Right? So you can have a thread that's constantly monitoring all the connections in your app. All right? So it can run a task every 2 seconds, every 4 seconds, or every time the mouse is moved, or something else. Okay? Just a second here. Yeah. Now, so we'll start off with much the same as before. Now we have a variable called count, which is going to be the static variable. Okay? Now, so we've previously been using our service. What we've been using is an executor service. Now there's a subclass of executor service. It's called, these guys really roll off the tongue. Okay? A scheduled executor service. Okay? Is equal to executors, and this one really rolled off the tongue. This is a new single thread scheduled executor. Okay, so what is this? This is the object we use to control threads that have tasks that will run at some point in the future. Okay. So this creates a thread. Now, it's a thread that allows you to schedule tasks to be carried out at certain points in time. Okay. Now, you could end up in a situation here, you need to be careful with doing these, lads. You could have a thread where you have, it's got 5 tasks. Now, you can choose whether to run these tasks 5 seconds after your thread first starts, your first task kicks in, and it's going to repeat itself for every 10 seconds afterwards. You can do that sort of thing, okay? Or you can run through the first 5 tasks, and you do that every 15 minutes or every 10 minutes. Or you can have the first task going every 10 seconds, the second task going every 4 seconds, or whatever. Okay? Now, if you are going to do this, make sure that if you have tasks, 5 tasks, and if one task is getting a value from another task, you have to make sure that they're scheduled correctly. What do you mean by that? So let's say our first task gets us the sum. The second task multiplies the sum by 2. The third task multiplies the previous, so this gives us a total. And the third task divides the total by 2. All right? Now, task 2 won't run until task 1 is run. Task 3 won't run until task 2 is run. Yes? Now, if you're doing them as scheduled, and let's say you want to do this every 4 seconds, you still have to make sure that that one comes first, that one comes second, and that one comes third. Do you understand what I'm saying? If you're scheduling them, let's say if you schedule that to go every 3 seconds, you have to make sure that this one also goes every 3 seconds, and this one also goes every 3 seconds. Because let's say if you schedule that for every 2 seconds, and that one for every 4 seconds, well, it's going to throw all your calculations out. Do you understand that? So one way is to make sure is to put in some sort of delay between those 3 tasks, or amalgamate those 3 tasks into one task. That's the choices you face. Okay?
But if one was set to go for 3 seconds,
yep,
the other 2 now have to be set to go for 1 second.
They'd have to go 1 second after it.
So
yeah, that's what I mean.
Right.
So you do have to know your, but there is, now the 2 basic types of schedulers that we use, okay? There's one that is very basic, and there's one that's slightly more complicated but allows you to do more, okay? Now, the whole idea of schedulers is obviously you're going to be repeating this. You're not going to just run something just once, all right? The whole idea of scheduling something, for instance, the virus scanner on this one's every 15 minutes. All right. I actually even think I know the name of the thread. Let me just have a look at it here. As far as I know. So let me just have a look here. Virus scanner. I think it's Windows Defend or something. It's called. Let me just see. WIN. There it is. Windows Defender's antivirus service. Okay, that runs every 15 minutes on Windows. Okay, it checks your machine every 50 minutes to see if there any suspicious activity. That's a service. That is a scheduled service. That's exactly what this is. Okay, so, but this is set to every 15 minutes. Now, I think you can actually change that, but the default is 15 minutes. All right, so that's an example of it. And in actual fact, all of these guys here, see, some of them are running, some of them have stopped. You come on later on, you'll see half of them are running again, the other half has stopped. So they're all the time constantly starting and stopping. Now, some of these services will run when you open a particular application or when you do a particular thing. Some of them are set to come on at a particular schedule. Some of them start running when you do something. These are the ones that come on at a particular point in time. All right? Now, so schedule executor service equal executor new to single thread scheduled executor. Okay, so this is a thread that you can schedule the tasks to happen at a particular point in time. Now, so to see the point in time, we need to know what time it is before anything happens. Okay, so at the very start, we're going to say time is local time dot now. Okay, so to see our scheduler executor in action, we need to know what time we start at. Okay, so that's going to be the time it starts at. Now, so service can use, again, it can use, so it can use runnable or callable, okay? So we can use runnable objects or we can use callable objects. Now I'm going to create runnable objects and callable objects here to cut down on code, all right? So I am going to create a, let me just see now. I'm going to get a runnable task. Runnable task 1 is equal to, so what I put in here is the void run method. So I'm just going to put in here, that's why so, fuck yeah. So I'm going to put in here, so time of first task is local time dot now. And I'm going to say, I'm going to also have a counter. So I'm going to say runnable task count is, I go plus and plus plus count. Now, as well as a runnable, you can use callables, okay? So this is going to be a callable of type string. I'm going to call it task2 is equal to now I'm going to put inside here time of second task is plus local time dot now. I'm just going to create a string inside here. So string I'm going to create is horse plus 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 count. I'm going to print out the count. I'm going to return the string. Now, as this is a callable, you could put in a sleep. I'm not going to put a sleep in this one to make things, I'm not going to make things complicated. I'm not putting in any sleeps. All right? No sleeps used here. All right? Now, so I am going to use the schedule method. So what's this? This is schedule method of the scheduled executor service. Right, now, so this guy's service here is a scheduled executor service, okay? It's a new scheduled, a new single thread scheduled executor. So this is for doing something in the future, all right? And the method is schedule. So I'm just going to, so future, question mark, result 1. Now, we're going to use schedule with a runnable. Schedule with the runnable doesn't return a data type, it just returns a future object. Okay? If you have a callable, so a runnable returns void, so you can't have a data type in here for that type of future object. So we go service dot schedule. Now, there is 2 schedules we want. It's a schedule with the runnable. Okay, now, so first thing that goes in is the task. That can be a runnable or a callable. In this case, it's a runnable. The runnable is task 1. Okay. Next thing is, this is the amount of time you want this task to run after the thread has started. Okay, so if our thread starts at 13:48, or sorry, 13:48 and 58 seconds, this task will not run till 13:49. I'll show it to you in a minute. Okay, so it's going to start 2 seconds in the future. And the unit is, this is the time unit we want to use. So we're going to go time unit dot seconds. Now we'll make it more than 2 seconds. We'll make it 5 seconds. All right. So what all this means is that this task is going to run 5 seconds in the future. That's it. Okay. Now it should be 5 seconds on from that time. So whatever time it has here, the time when it's running the first task should be 5 seconds in the future. Did we get that? Let's say that again. So let's say this time here is going to read, let's say 13:49 and 30 seconds. Okay. This thread here, it's not going to run until 13:49 and 35 seconds. Does everyone understand that? Now you can say, you can change that to any time unit you want. It can be, sorry, hours, I think is the max. Let me just see. I think hours is the only one you can use, I think. Let me just see. So you can go time dot, actually you can do days, hours. So days is the most one you can use. Okay. Can't use weeks. Can't use months. Why could you not use months? Why can't you use months? Because you don't know what the month is. It's not a set time period. This cannot. Sorry.
Doesn't take it.
No. Doesn't. It's not smart enough to do that. So we're going to say 5 seconds. Now, so what this should now, I haven't dealt with the second task at all. All right, we're only doing the first task. So, and you don't need it in a try catch block either, but that's neither here nor there. Actually, I will put in a try catch block. So I'm going to put the try block here. Put everything inside the try block. And then we have a catch. And then we go if service that is shut down. So if it's not shut down, service dot shut down. Okay. Now, so it's EX10. Just give me a second. Right. Now, so we're going to try and run, and hopefully this runs the way I think it should run. Okay. So we're only running this task. Okay. So we're only running this task. Okay. Now, this is going to print out the current time. All right. Then it's going to wait 5 seconds. Okay. It's going to wait 5 seconds and then it's going to run our task. Okay. Think of it, the time it should have started, it adds 5 seconds onto it. That's the way it works. Okay. So this time, so this task, sorry. This task should run approximately the same time as this task if they weren't scheduled or if you didn't have a sleep in it. What happens is this runs and then 5 seconds into the future, this will run. Is that okay? Let me show you. So I hope it prints off anyway. Yep. So time is 14:15:33. Yep, there we are. Now, it's not going to be exactly 5 seconds, right? But it's pretty damn close. There is, now them are nanoseconds, a 70 billionth of a second incorrect, so it's still fairly accurate. So you can see what happens here. It starts at 14, so this, the time before any thread starts is 14:15 and 33 seconds. Okay. Now, it should start at a particular time. It doesn't. It should start at approximately this thread here.
Darlene O'Malley, contact reception. Darlene O'Malley, contact reception, please. Thank you.
That task should start approximately at the same time, but it doesn't. It's delayed for 5 seconds. Okay, so task 1 starts 5 seconds into the future. Why is it seconds? Because I have seconds there. Okay, so 14:15 waits 5 seconds. Then the task starts. Time of first task is local time dot now, which is going to be 14:15 and 38 seconds. Okay, everyone with me so far? Yes. So all you're doing, you're scheduling for 5 seconds in the future. Now, that's using a, this is using runnable. Okay, task 1 is runnable. You can also use a callable. So I'm going to use a callable. So I am going to go here. Now you don't have to assign it to a future object, but I'm just assigning it to future object to show that you can. So this is going to be future object. It's a string. Why do I make it a string? Because this is what the callable is returning here. All right. So future string. I'm going to call this result 2 is equal to service dot schedule. So it's going to be the callable. So this is going to be task 2. I'm going to put in a delay. Now here's the important delay is. If I put in 5, what happens there is that that guy is going to run at the same time as. So if I put in 5, So if I put in 5, that means that these two are going to run at the same time. All right. So if I want that one to run 2 seconds after this one, what should I put in? 7. Yeah, exactly. Or ideally what you do is you'd have a set time period up here and you just add 2 to it. So let's say if I change int time is equal to 5, and I put in here time, and I put in here time plus 2. And what is it going to be? It's going to be time unit dot seconds. So this one is going to run at 5 seconds in the future. This one is going to run at 7 seconds in the future. Okay? To prove that it works. Now, so it starts off at, I'm sure there's nothing above that. Okay. So it starts off at 14, 19, 52. Okay. Then it goes forward 5 seconds, which is the time of the first task. It goes to 14, 19, 57. Okay. Next one. It's 2 seconds after that is going to be 14, 19, 59. Okay. Now, what's actually happening there, by the way, with the scheduling is that the thread is being put to sleep. All right. There is a implicit sleep there. It's been put to sleep for 5 seconds. It's been put to sleep here for 7 seconds. It's just a little bit neater and tidier than using actual sleep. Is everyone with me so far? Yes? Okay, so I have to put in the comments. So this is our first task. Our first task to be added to the thread. And this is our second task to be added to the thread, callable, can returns an object. Here it's a string. Anyway, so this guy down here. Now, we will run the first tasks 5 seconds in the future. Okay. Now, this is 5 seconds from the time it would have run if this was just a normal task on a thread. Okay, so it's 5 minutes after it would any other, or 5 seconds after it would have run if it was just a normal task on a normal thread. All right, it delays it for 5 seconds. So schedule takes three arguments. A task which can be a runnable or a callable, a amount of time, and a unit of time. Now it goes, which can be nanoseconds to days. All right. For instance, another thread in Windows that checks every 7 days for updates. All right. There's a thread in Windows that checks every 7 days for updates. So even when you shut down your machine and turn it back on again, these threads are live. That's the best way to describe it. All right. So they're all the time there. Anytime you're in your app, the old internal clock is going there. All right. So now this task, we will run the second task. Seven seconds in the future. This is the time it would have run if this was a normal task on a thread. If this was 5 seconds, it would run the same time as task 1. So you need to put it 2 seconds after the previous task. Now, these guys are fairly, it's an easier way to schedule all your stuff. All right, rather than sleep. Sleeps are just, I mean, there is sleeping going on here in the background, but they're easier to manage. Okay, so this will be, so up here, 5. So this is our base time, our start time. 5 seconds after our start time. Now it's not going to be exact. It's going to be a couple of nanoseconds out, but Jesus, that doesn't matter really. Okay. And this one here is going to be 7 seconds after our start time, approx. Okay.
No, the method there, schedule.
Yep.
What's that return again?
It's returning a future object. Just like submit returns a future object. Okay. Now it's not actually, the specific type I think is a scheduled future, which I think is a subclass of future. So future will do fine. I don't know what scheduled future is, but future will be fine. Now, no, the future object in this case holds the string count horse plus count. Now this future object just holds information about it, whether it's cancelled or whether it's terminated. There is no value as such in that one. There is value in that one. Okay. Now, so that's fine. Now, so you might think, yeah, hold on. I should be able to put a task in a loop and the task should go 5 times and it should be separated by 2 seconds each. Yes? I'll show you what I mean. Yeah, right. So we're going to do static void EX11. Because that's what you want. When you're scheduling something in future, you don't want to do it just once. If you're working on your app, if you're providing constant security for your app, you want it to run every 5 minutes. You want it to run every time the mouse is run. You want it to run every time. Well, for instance, here's another idea of a thread. You're playing a computer game, you press right, there's a thread that controls all of the movements to the right. You press left on your keyboard, a thread runs that controls all your movement to your left. That's the way they work. Okay? Now, so, or a certain point in time. So we're going to do a second one here. I'm just going to copy same guy again. That lad. Put him down here. And I have a static variable called count, and I'm going to set it to 0. Now, I am going to do a try block in here. And I'm going to do catch. And I'm going to do a finally. And I'm going to say if service is shut down. So if that's not true, we go service dot shutdown. Right. Now, so inside the try block, I'm going to have a for loop. And this loop is going, I just, for int I is equal to 0, I, it's a long time since we used a loop, less than 5, I, plus plus. Now, inside that, I am going to create a service scheduler. Service dot schedule. Now it's going to be a callable. Now the callable part so the callable part is going to be this. So I'm going to go, it's going to be a callable, it's going to return something. The delay is going to be 2 seconds. Time unit is going to be seconds. Now, so what goes in here is your scheduler. Okay, so the first thing I'm going to put inside here is a print statement. I'm going to have a counter inside it. So count is plus count. And time is local time now. Okay, now this is going to be, I'm going to make this a callable. By doing this, that means that this guy here is a callable, not a runnable. Okay, so by putting in a return statement and null, that means that this guy here is going to be a callable. That means we can put thread.sleep inside here. Okay, this makes this a callable. Okay, so it's not a runnable, it's a callable. Now, so, but before that, so it's incrementing by 1 each time. Okay. Now, if count is greater than 4, now I'll explain what I'm doing there. Right, this is going to go 5 times. Okay, we're going to create 5 services. We're going to have 5 tasks. It's going to create 5 tasks, so this is going to go 5 times. Okay, so counter is going to keep incrementing itself by 1. When this guy gets to 5, okay, when it gets to 5, this count here is going to be 5, and it's going to print off task all complete. Does everyone understand that? Yeah? Right. Okay. And so looking at that, you would think that it will do 2 seconds in the future, and then each one, the 4 after that, are going to come at 4-second intervals or 2-second intervals. Yes? Yes? I'll say that again. To look at that, what we think it should print off is count is 1. So this is what we're trying to achieve. We're trying to say count is 1, time is, let's say, 14, 20, and 50 seconds. Time is 14, 20, and 52 seconds. 14, 20, and 54 seconds, and 56 seconds, and 58 seconds. Yes? Right. So you'd think that's what I do, wouldn't you? I remember the threads. Okay. And look what actually happens. So EX11. Oops, sorry. Now it'll wait. See what happened? They all run approximately at the same time. Why is that? Anyone hazard a guess as to why it's doing that? Because this scheduler, this only is when the first task in the thread starts. Okay, and here's the thing, all the tasks in the thread start at the same time. All right, I think I said at the very, very start of this that you wouldn't want to be relying on, there is something called a task scheduler which manages your tasks, because it is possible for all your tasks to run together at the same time. They're there. They're all on the same thread. So it is possible for multiple tasks to run at the same time on the one thread. That's the situation there. Because all it's saying there is, right, we want to start our thread 2 seconds in the future. When you do that, all of the threads start 2 seconds in the future at the same time. Now, approximately. The first one is always going to start a couple of nanoseconds before the rest of, but the other 4 start at the exact same time. So the question I would ask you here is, how would we get those to have 2 seconds apart? Say that again? Exactly. That's one way, okay? Now, one way of doing that is, now this is, there's a reason why this is callable. Okay, I made this a callable so I can put thread.sleep inside here. If I put in thread.sleep in here, so if I make it here and it's thread.sleep, now it's 2000 milliseconds, which will be 2000. Now that will, for every task that's added to it and completed, it's going to wait 2 seconds until the next task is started. Okay, so watch the way it goes. So 35 seconds, 37 seconds, 39 seconds, 41 seconds, 43 seconds, tasks all complete. Okay, now that's one way of doing it. There is another way of doing it. Okay, and probably this next way is probably a better way of doing it. Okay, so just to clarify this, so I'll put it in the comment. Now, so I'll take out the thread.sleep. Now, so I'll put it in here. This will run all the tasks approximately 2 seconds in the future. 2 seconds from where it, two seconds ahead of the time it would have run if they were normal tasks in a normal string. So all tasks will run at approximately the same time. Okay. Now, sometimes you'll get slight variations amongst all of them. All right, so I'll take out the sleep again. It waits 1,000, 2, 1,000, 3, 1,000. So 219, 234, 234, 234, 234. Sometimes you can see those 5 numbers being different. They're all running approximately at the same time. So what you do is, each time a task has nearly finished, we put in a sleep. Or you could put the sleep in at the start as well, by the way. If this is returning something, you can put a sleep up at the very start. Do you understand that? If you put the sleep up at the very start, so it won't start for 4 seconds. One, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, well, approximately 52, 54, 56. It's probably to put the sleep, better to put the sleep at the start. Okay, so your initial startup time will be 4 seconds. Okay, because the first thing it does when it comes into the first task is it puts itself to sleep for 10 seconds. So if something was happening before it, it gives us 2 seconds of a lead in. Yeah? So what this is doing here, up here, at the start of each task, we put the task to sleep for 2 seconds. So the previous task is given time to finish. Simple as that. Okay, so when you're putting sleeps inside a service, you usually put it up at the top, not at the bottom. Okay, so this is going to go start off at 4 seconds in the future, and then it's going to go on 2 seconds intervals. So this will here. Now, so if we have no sleep, happen, comment out the above lead to see this. Okay, so this guy here, we have a lead in time of 4 seconds for the first task. Then every other task in this thread will come at 2 second intervals. Okay, so we have 5 tasks. Okay, so we have 5 tasks now. It's not 5 threads, it's 5 tasks in the same thread. And it is possible to run all of the tasks at the same time. One way of doing them is to use the scheduling without a sleep. If you do scheduling without a sleep, all your tasks will run at the same time, which, by the way, you might want to do. You might want to create your GUI, connect to the database, connect to various services at the same time. That's not necessarily a bad thing, all right? But if you want your tasks to go in a particular order, then you use sleep. So it's not always a bad thing to have 2 or 3 things happening at the one time, as long as those 2 or 3 things aren't directly connected to each other. You're creating your GUI, your initial start page. It's not connecting to it, doesn't rely on a connection to a database or a value from a database. You're creating your initial start screen. It doesn't depend on any artificial intelligence agent that you might be connecting to in Azure. All right? So those 3 things can set up independently. Now, I'm going to show you the alternative. Instead of using this type of scheduler, there is another type of scheduler. The names are just capital. New single thread scheduler executor. Jesus, that hardly runs off the tongue, does it? Now, so let's see. Right. So static void ex12. Now, so again, this is schedule executor service, executor new single thread schedule executor. Jesus Christ. And count is going to be equal to 1, 0. Now, I'm only going to use a runnable this time. You could use a callable, but I'm going to use runnable. All right. Now, runnable task 1 is equal to and I'm going to say runnable task 1 plus 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 count. And then time is plus local time now. Now I could have typed that in the service, but I don't care about it. Okay, so just making it normal. Runnable task is plus plus count. Time is local time. So this is a slightly different scheduler. Okay, so we've seen the scheduler that can take either a runnable or a callable. Okay, now there's another type of scheduler. Now, this one is called the following. So it is service dot now SCH. So you can see the two schedules we've done. Okay, now the next one is schedule at fixed rate. Now, it takes 4 variables, okay? The first variable is the task that you want to add to your thread. It has to be a runnable or a callable object. Now, your initial delay, so the very first time you start up your thread, the very first task, you should give a little bit of extra delay. All right, so the first task in the thread is going to wait 5 seconds before it starts. Okay, so the very first thread, or the very first task in our thread, is going to wait 5 seconds before it starts. Now, all other tasks in the thread are going to be at a time period of 2 seconds. Okay, and the unit we're going to say now. Here's the bit that I'm not 100% sure how this works, but it works. So let me just see. Oops, that's inside the runnable. Give me a second. Right. Now, I am going to go try. I am going to go catch. I'm going to finally. And we're going to go if. And I'm going to say is shut down at right. Now, best thing to show you is to explain what's happening is to run it. Okay, now here in the try block. Now, how long you want to run for is what you put in here. All right, that's what you put in the try block. Now, so let's say if I put in, now this is the format, you go time unit dot seconds dot sleep 15. Now, I'm not too sure why you put in sleep, but that's neither here nor there. What that means is that your service is going to run for 15 seconds. All right. Now, So I'll explain what happens. It's not going to start until 5 seconds into the future. All right. So that means it's going to last for a total of 15 seconds. So that means you've only got 10 seconds left. Do you understand that? Yes? So you have a time here. Let's say 3:51 and 20 seconds. It's not going to start until 3:51 and 25 seconds. And it's going to go on for another 10 seconds, and it's going to finish at 3:51 and 35 seconds. Okay, so it should go 5 times. All right.
And the 2 doesn't come into it then, no?
Sorry?
The 2 doesn't come into it, no?
It does, because it goes every 2 seconds.
It'll keep doing the same task.
Every 2 seconds, yeah. Until it gets to 15 seconds. Okay. Now you can change this to until the app is shut down. I'm not exactly 100% sure how to do that, but you can. All right. So you can have your thread running every 2 minutes until you shut down the app. I'm not too sure the command you can put in there, but there is a command for it. All right. Here, it's going to just go for, so this guy is going to read 31:51:20. It's not going to start until 5 seconds after that, and then it's only go on for 10 seconds. So that's a time, that's a total time period of 15 seconds. So it should run 5 times, I think. So I'll run it. And we'll go here. Okay, so 1,000, 1,000, 1,000, runnable task. Okay, so let me just see. We started at 10 to, yeah, I don't have the time before it started, right? So I need to put that in here. So sorry about that. So time at start is plus local time now. Right, so we started 14:56:52. So the next time should be 14:56:57, 59, 01, 03, 05. Now, so sometimes you might get 6, sometimes you might get 5. Okay, can't be guaranteed that you're going to get 5. So it's purely time dependent. It's only going to go for approximately 10 seconds. So I'll explain the whole of it here. So it starts at 52 seconds. Okay, so it should have started at 52 seconds, but it waits 5 seconds and it starts at 57. Okay, then it goes to 59. Then it goes to 01, then it goes to 03, then it goes to 05. And we see it finishes at 07, which is a 15-second difference between 52 and 07. That's it. Okay, I'm not too sure why you have to say sleep there.
I think it's just so you can't use the time limit.
Sorry?
It's so that you can't use time limit again. That amount of time because time limit is busy being used with the schedule.
I don't know, Jason.
You know what I mean?
Oh, so the time unit has been asleep for 15 seconds.
15 seconds.
Yeah, that's probably what's happening. How does that? cause it to just go 15 seconds. Okay.
I'm seeing that as.
Oh, right. Because here's the thing, right? So if it puts that to sleep for 15 seconds, that means that this is going to go every 2 seconds. That's what it is. I think.
Would you not, after 15 seconds, would not start all over again?
No. No, because you see, right, the previous one.
Like it would continue on, it would pause for.
Right, if I don't have a time unit in it, it only runs once, okay? Because the time unit is what tells it to stop, right? Because see up here, the scheduler only runs once, okay? Now, if you turn off the time unit, or if you put it to sleep for 15 seconds, that means that this guy can go for 15 seconds. Now, there is other ways of doing it besides that, okay? There is other ways of doing it besides that. But this is something called schedule at fixed rate. That's the initial lead-in time. That is the amount of time between each tasks. If you don't have that guy in there, it'll only run once. If you have that guy, it'll run for 15 seconds. Now you could have a thread inside a thread, by the way, I'm just thinking of it there. You could have a thread that runs every 2 hours, and inside that thread could be this thread that's going to run 5 tasks in 15 seconds. Or you can have a thread calling a thread. So I'm going to put the comment in for this one. So what does this do? This is going to complete a task. Tasks. Okay. The first task will have a 5-second lead-in time. Every task after the first task will have a 2-second delay. Okay. This is the time period the task will be repeatedly done. Okay. The 5-second lead-in time is included in this 15 seconds. So we only have 10 seconds of tasks, which can be 5 tasks, 6 tasks, or even 4 tasks. So it's not a set amount of tasks, it's a time limited amount of tasks. So it's not a set amount of tasks, it's a time limited amount of tasks. Now, you can put in, I'm not too sure what else, there is other ones you can put in there that if you do something, you can have the scheduler running constantly in the background, and because you don't want to shut off the time unit, because if you shut off the time unit, it causes issues. So there's obviously some other way that I don't know of that you can have a scheduler running in the background continuously without shutting off the time unit. All right, so I'm not 100% sure. I'm sure there is some way to do it.
So you can only schedule with some form of
Sorry, Jason?
You can only schedule some once a week. You can't like give tasks a certain priority.
Oh, you can, yeah. There's priority threads. Oh, I just said you can, yeah. Oh, can you? Yeah, I think we do that as well. Yeah, there is priority threads. Oh, yeah, yeah. No. Right.
The schedule will only go through set task once.
Sorry?
The schedule will only go through, the schedule method will only go through the tasks once. As well, is it?
Well, no, because it's going through the task repeatedly. Okay. So what it's doing is schedule at fixed rate. It's doing this task 5 times, 4 times, or 6 times.
So it's wrapped into the separate.
Right. So schedule at fixed rate. It's going to perform this task. Okay. It's going to perform this task 5 minutes into the future. And then it's going to perform the same task at 2-minute intervals. Okay. Or 2-second intervals. Now, how long is it going to do this for? 15 seconds in total. Now, the 5 refers to the first 5 seconds. So that leaves us only 10 seconds to do actual, which makes sense because there's obviously going to be, could be other sorts of exotic stuff happening before this. So you've only 10 seconds to which to do a certain amount of tasks at 2-second intervals. Sometimes you might only get 4.
Is it parallel sequence?
No, this isn't parallel sequencing. No, it's parallel sequencing at the same time. These aren't at the same time. That's the whole idea of scheduling, so they're not at the same. Yeah, it is asynchronous, but I wouldn't go into those big terms that it's just one after another. That's as simple as that. You're scheduling your tasks to run at a specific point in time in the future for a specified. Now, you can specify. Now, there's also a way. I forget how to do it. You can specify a day in the future to run every 2 minutes. Now, I'm not 100% sure how to do that, but you can do that. So you can say 2 hours in the future, I want you to run these 5 tasks at 2-second intervals. Every 2 hours, I want you to run these 5 tasks at 2-second intervals. You can do that. I'm not too sure how you can do it, but you can do that. Also, you can have it running constantly in the background as well. Doesn't matter. It's wherever your development environment is. In my case, it's wherever it is, but it doesn't matter where it is. Doesn't matter. It's the cache. So it's the Eclipse cache. So.
Is there much protocol then for?
Sorry.
Is there much protocol to bypass if you're working on another computer? Maybe not in
Hyper-V. All you're doing is creating variables here. You're not accessing anything. Yeah, but that's threads are not about accessing stuff. Threads are about you've already got the stuff. That's totally separate. Yeah, it's no, the threads are all about doing something. Threads are about not. You could be getting something from a database, but that's different. That's JDBC. It's nothing to do with threads. No, a thread is just a series of tasks. That's all a thread is. You don't have to have thread. You can use threads to do that, but that's kind of a different topic. Threads is just a series of tasks. It's a series of tasks. That's the best way to describe it. It's just an object that is a series of tasks, and those series. Of course, it can. Yeah. Anything can run. It's a series of tasks So it's a logical unit of work. Your GUI, your databases, your files, your Azure stuff, your whatever, your testing stuff. It's just a unit of work. So it's just a series of tasks. That's all a thread is.
So if the computer breaks down, you should be able to fix it now.
Threads?
With it, yeah. Update your services.
Yeah, but we wouldn't be able to do anything with it, because this is just an app we're doing. These are threads in our program. Nothing to do with the system threads. These are not. When I'm talking about a system thread, I'm talking about the system thread within Java. The Java system thread. It's not the Windows system thread.
Oh, so you can't work on Windows, but Java can work on
Yeah, but that's got nothing to do with. This is purely an application we're working on. All of this stuff is just our thing. It's not interacting with Windows. Doesn't matter if it's Unix, doesn't matter if it's Windows, doesn't matter if it's Apple Mac. It's platform independent. So you're creating a thread within the JVM. You're not creating a thread within Windows.
Can you alter what's on Windows?
Through this, I'm sure you can, but we don't want to do that. Why would we want to do that? We don't want to do that. We don't want to do that. Of course you can. No, we don't want to do that. No, we don't want to do that. We do not want to do that. No, do not modify Windows through this. I would not recommend that, because that can have totally unforeseen circumstances. You can, of course, but I wouldn't do it. Where am I talking about now? So this is a scheduler that's going to run 5 seconds in the future, and after that's going to run for 2 seconds. And how long is this all going to take? This is going to take 15 seconds. Okay. Now I'm trying to see the other topics that I have here in the threads. All right, we'll start on this. Okay, so we'll start on this. So I'm going to go down here. Now, so this is scheduled at fixed rate, isn't that it? Yeah, okay. So we don't need to use at sleep. Fixed rate, is that the right one? Hold on a second. I have one more. Now, the thing about these guys, right, I'm seeing it here, is, again, you need to be careful. This will submit. So you have 5 tasks. Let's say one task is taking longer than 2 seconds. All right. The 2 tasks then start running concurrently. All right. It doesn't stop one task and start another one. It doesn't wait for one to be finished and then the next one to start. That's not the way it works. Okay. By using this, you have to make sure that all your tasks are completed in 2 seconds. So I'll put in here, make sure all of your tasks would complete in 2 seconds, as each new task does not wait until the previous task is finished. Okay, so you'd have to make sure that if you are going to use these schedulers, you have to make sure that that each of the tasks I'm going to complete in 2 seconds. How would you do that? What you do is you would put that task in a loop and you would run it a couple of thousand times, the loop. And then you get the average of all the times. You could do a little stream that would run that 1,000 times, because that is a for each. You could put that in a for each in a stream. And you could time how long it takes to do each one of them. And
it's only in your system.
Huh?
It's only in your system.
Yeah, but we're coming up to a place now where you can tailor the threads to your system, which is what you really have to do, okay? We're making it more complex each time. What Jason's talking about there, threads depend on your system. The better your system, the better they run. All right. Actually, I'm gonna skip a bit. Okay, I'm just gonna skip a small bit. So I'm gonna leave the bit about thread pools until tomorrow. 1-800-387-2331. That's a funny fucking number. 1-800-387-2331. Sorry, but I'm not going to answer. I know, it's probably someone offering me €1 million. Do you know, like, I got an email there the other day. Or I got another one to make me more attractive than you already are. No, and I said, Jesus. I nearly felt like emailing the back. That's not possible. Anyway. Right. So, now this is kind of going ahead again, but I just briefly want to show you this. So, static void. This would be EX 12, so 13, 14, 15. This would be 15. All right. So I'm just going to. So here's all the different. Now, so I run these guys. Right, just quickly run them. Fuck. Okay, come on. Just run the other thread. That's EX15. Fuck yeah, sorry. Right. So now that's the amount of processors that are on my machine. That's the amount of RAM I have available in the machine. Okay, I think that's the maximum amount of RAM. Now there's something wrong there because I have 64 gigabytes of RAM. I don't know why it's showing up there only as 16. Maybe it can only take 16. Now there is going to be something we're going to be doing tomorrow. All right. Now, we are going to create something called a new scheduled thread pool. Okay. Now, these are multiple threads. All right. Now, you have multi-threaded applications. So what you do is you create the amount of threads that your machine can handle. So if you've got less than 2 processors, you're going to create a thread pool of 4. If you have greater than 4 but less than 8, you're going to create a thread pool of 18. Else you create a thread pool of 16. What you're doing is you're managing the amount of threads according to the system. So the faster the system, the more threads you can have. The more things you can do. Okay, so you can have 16 threads running at the same time, or you can have 4 threads running at the same time. That's the way you use threads. So we'll be doing these guys tomorrow. These are, they're called scheduled thread pools. These are multi-threaded these are threads that are going to be running. You want them to run beside each other. Previously, we didn't want our threads really to run together. These guys, we do want to run together. All right, is that okay?
That's different from there's a regular thread pool as well, isn't
It
it?
is, yeah.
Which is full of however many you want.
Yeah. Well, because these ones here, these are pulling them from a thread pool. All right. So it's, you know, like the string pool, it's the same thing. They're just ready and they just pull one out. But this is your own. Best way to describe it. Okay. So that's what we're going to be doing tomorrow. All right. So we're going to be tailoring an application to the machine you have. So the beauty of this is, doesn't matter what machine you run it on, it's going to adapt itself. So if it's a lower powered machine, it's only going to operate 4 threads at a time. If it's a more high powered machine, it's going to run 16 threads at a time. Or, now I presume it's only showing 16 gigs RAM here because maybe Eclipse can't handle more than 16. Maybe, I don't know. Anyway, that's that finished for today. I'm going to